Hello and welcome to this Edge Are You Ready session. Today, my colleague Juan Herrera and me, I am Andrés Valero, by the way, will be talking about edge computing and different use cases and how SUSE can help you with your edge journey. So, as I already told you, my name is Andres Valero. I work as a technical marketing manager at SUSE, and with me today is my colleague Juan Herrera.
Hello, hello everyone. Welcome to the session. Juan Herrera working together with Andrés Valero in the technical marketing team.
So let's get started. So first of all, we'll be covering a small introduction to Edge. Then we talk about types of Edge or the different qualification use cases. We'll be introducing and focusing on one concrete use case. Once we introduce the use cases, we will talk how SUSE can help you in your Edge journey, and we will speak about the conclusions about all this talk and the edge landscape. And last but not least, you will have some time for Q&A. So let's start with what is edge computing. So TechTarget defines edge computing as a distributed information technology architecture in which client data is processed at the periphery of the network and close to the origin of the source, so closest as possible. But also, many of the different edge computing definitions talk about an architecture which improves the data flows since data is processed as close as possible to the source in order to improve latency and avoiding sending lots of information from the source to the data centers or the cloud. So we are speaking about distributed computing. And why edge is important, why edge matters, because the spending on edge computing is expected to be like almost 180 billion with B in 2022, being an increase of almost 15% over 2021. So enterprise service providers are spending hardware, software, and services for its solution growing to 2025 until 274 billion again, as per IDC Worldwide Edge Spending Guide. So it's a market that is growing, and the amount of money invested is growing a lot. But also, if we speak about Gartner's predicts cloud edge and infrastructure, Gartner says that IoT forecast is showing that by 2029, more than 15 billion IoT devices will attach to the enterprise infrastructure. And this is going to be very important, and this is going to be a really game changer when it comes to our infrastructure, security, and how we manage things in the future. So, when I think, or at least when I thought about edge, I always thought about a Raspberry Pi, small computers, Intel Nuke, something like this. But the reality is pretty different. Everything is or can be an edge device where we have compute at our disposal to process information and gather information. So, for instance, a common car, has between 25 to 50 CPUs. Then, personal devices like smartwatches or smart grids, city cameras, they are not only generating large amounts of data, but also can be considered like an edge device that can run software. The potential market for edge is growing alongside our society. You just have to think about 5, 10 years ago. You had your TV. You probably was a common TV, not smart TV. You had a couple of phones at home, but no Alexa devices, no smart switches, no cameras at home. Who had 10 years ago a camera at home? No one. And today it's something pretty common that you have security cameras installed at home. So the potential growth of edge, it's and I'm being redundant here, it's growing every day. And in such a landscape, why SUSE is important? Well, most of these IoT and edge devices use Linux. They need a lightweight, secure, and reliable OS to run. And who better than SUSE and our experience to provide Linux solution for Edge? But also, when we talk, and we were talking about this at the beginning of the talk, so when we talk about distributed computing today, or distributed computing, we talk about Kubernetes and containers. And we have Rancher in our SUSE families, and we can provide you with different solutions to manage containers, clusters at scale. So we really can help you here. Now, I would like to introduce the different concepts of edge and introduce general use cases and a very concrete one. So, if we consider that the right side, so the cloud and data center, cloud infra, is the origin, we will be qualifying the kinds or the types of edge in depending on the distance to this cloud infra. So first of all, we have near edge. Near edge would be regional disease, telco use cases. So basically, this is the domain of telco and entertainment providers. When we talk about far edge, we can talk about energy industry, aeronautics, government, retail, automotive. So fintech, almost any vertical you can think of is a far, or they have edge use cases. The amount of edge use cases are almost uncountable. You can have millions of them. And then there is the tiny edge, that is a very concrete use case or qualification in this case inside the far edge. So we can have mobile phones, we can have gaming devices, we can have IoT. All of those are tiny edge, are small portable devices that are tiny, like the name says, but are really far from the cloud infra, but they generate huge amount of data. When we talk about architecture, we have to take in consideration that there is no one size fit all in edge architecture or edge solutions. So what I'm going to introduce you is a general architecture, simple one, but the architectures are defined by the concrete use cases. Almost every or each different use case at edge will need a concrete architecture and a concrete definition of needs. So in this case, we are considering that we have a hybrid cloud data center, so bare metal, maybe on premises or virtualization on premises. We have public cloud providers, and we have there some software that consumes or processes the data so the users can see the information they need. Then we have connected to the internet regional or edge data centers. In those data centers is going to be the software that filters and processes all the information coming from the edge devices, filtering and sending back to the hybrid cloud whatever is needed. Whilst it is connected to thousands or hundreds of thousands devices that will have probably containers running on them, and getting this information and sending back to the regional data center. And this is just an example. But today, I will be talking about few more use cases. These may or may not fit in this architecture. And later on, I'll show you, or I'll focus in a concrete, very concrete one. So, as I told you before, near edge is basically telco land. So VRAN, private LTE, 5G networks, and virtual content delivery networks. So media companies also. This is basically most of the use cases that you'll find in the near edge. However, when we go to far edge, the things change. We can have retail, so shops and malls, etc. So retail examples, healthcare, industry 4.0, smart grids, and today we'll be focusing on smart grids, and I'll explain what smart grids are. Public sector, in for defense, for instance, or tiny edge like IoT or mobile phones. So we have, this is just few examples, but there are thousands or millions of them. Well, we will be introducing and focusing today a little bit about smart grids. And smart grids are a pretty new use case. And smart grids basically are the future of energy distribution, will play an active and important role to achieve more sustainable future. But over and top will be key to ensure electric distribution in an efficient manner with great quality, low energy loss. And probably you're wondering by now, okay, you're talking about this, but what are smart grids? What are you talking about? So basically, a smart grid is an energy distribution grid that is able to integrate efficiently the behavior and actions of all the users connected to such grids. So this sounds weird and complicated, and it is a little complicated. So I tried to put here a diagram. Let's consider our smart grid a small village. So we can have houses that have solar panels and consume energy. We can have houses that have electric cars but no solar panels. All these houses obviously are connected to the common power grid. Or houses that, let's say, are a little bit more advanced. They have solar panels, they have also electric cars, but what all of them have in common is they have compute power inside the house in one device or another, and all of them are connected to the internet. Today, it's common that most of homes are connected to the internet. So this opens a door. Having compute power available at home and having the homes connected to the internet opens the possibility to smart grids. And the smart grids are aware of who is consuming energy, who is generating or can generate energy, and they can exchange or help the different houses or different homes to exchange energy in a bidirectional way. So we ensure that electricity is shared near where it's originated, and we make sure that we are being as efficient as possible. As per today, the power distribution grids or the electricity grids are some kind of smart. And during the last 10, 20 years, the smartness, let's say, of the electricity distribution have been growing, and we are more aware where are going to be, or where are big consumers, big producers, but we cannot reach this level of detail, this knowing if a house have solar panels and how many electricity they can share. This is what smart grids are bringing on the table, this level of detail. And as you can imagine, that means processing and sharing big amounts of data. And there is a new concept that I would like to introduce you that it's amazing. At least for me, it's amazing. So these new concepts are the virtual power plants. Virtual power plants are based on a smart grid. So a virtual power plant will be composed of many smart grids. And a virtual power plant is a cloud-based distributed plant that aggregates the capacities of heterogeneous distributed energy resources. So talking plainly, is software running in the cloud that connects to different smart grids and help to distribute and share energy. This is already exists in some countries like the United States and some countries in Europe. This is a very new concept, but again, we're talking about cloud, we're talking about software. So now my colleague Juan will introduce you how SUSE can help you in such landscape.
Thank you, Andres. So, uh, before jumping into the use case that Andres was describing, because we will give you a more detailed view about the smart grid use case, covering all of them may be complex, as he explained. The use case in Edge are quite different one from to each other, so they need a specific evaluation. So we'll try to focus just in one of them. But before jumping, it's important that you are aware of all the components we have in our stack, because many of them will be critical while defining edge on far edge, near edge, or all the types of edge architecture. So first is the Kubernetes layer. Nowadays, new architecture around edge rely on Kubernetes. Why? Because it's a common platform that can be used at all levels. So uh, companies building solutions in the space can work with that technology at the data center level, at the central management layer, work with containers, and they can leverage that knowledge and that way working and applying all that methodology and all those best practice on lesson learned to the local edge device management. That was a challenge in the past, okay. But for example, in the top layers, you can see we have a specific product for it that is called K3s. What's K3s? K3s is a certified Kubernetes distribution that is designed for a small footprint device. As we said, it's certified, so it can run any Kubernetes type of workload, but we have tried to reduce those components that are, let's say, optional to make it as more resources consumption reduced as possible. On the Kubernetes layer, it's not just about the Kubernetes distribution itself. We have RKE, RKE2, which are more tailored for data center use cases with additional services that are required to cover more generic use cases. And on top of that, what really gives the value on these scenarios is SUSE Rancher, which is a multi-cluster management solution. We will see later on, okay, that the architecture relies on having tens, hundreds of thousands of Kubernetes clusters, okay, distributed across our network, and Rancher, or with its multi-cluster management solution, will be able to control all of them. We are also able to provide cloud-native block storage that is able to run on top of Kubernetes. So on those locations where storage may be a requirement, we can provide that right out of the box. And it's also important to understand that on all these scenarios, security, it's really important. We are, as Andres was explaining, the attack surface of this type of architecture is huge. We are handling a lot of devices, so we need something, a security layer that allows us to have a view not only on what's happening at the network level, but also at the container level, and that's what New Vector provides. So if our Each scenario is focused on Kubernetes, on containers workload. The rancher related stack is able to provide that, but it has been already been a thing since some years, and we have been already working with the embedded ecosystem and with solution provider in this space. And there we can also provide traditional SUSE solution. What have we done? Okay, in that space, we have taken our traditional SUSE Linux Enterprise server with all its hardware certification, security reserve certification, built with a secure software supply chain approach. We have taken all that and we have created a version called Slim Micro, which is a perfect foundation to cover that kind of use cases. And it's available in both x86 architecture and what is more common on these scenarios is ARM architecture. If we are going just to manage its devices as if they were server or more server, we can leverage SUSE Manager as the lifecycle management environment. SUSE Manager can control all those devices, can provision device, and can control the software distribution. So both scenarios, we are able to offer end-to-end solution. Okay. And for this, in this green layer, the more traditional one, we have a really good example in retail, and we even have a specific version of SUSE Manager for retail that has been offering this type of retail edge use cases for a long time. Last but not least, we have Harvester, a new product, one of new products in the portfolio. What Harvester does is links or helps to link Kubernetes workload or traditional workloads to the hardware. Okay, Harvester is a cloud-native virtualization layer that runs on top of bare metal, and it's quite common nowadays in many of those scenarios because, for example, in 5G towers or regional servers for smart grids that they have enough power. Usually they require a mix of containers workloads and virtual machines, and Harvester is able to provide that. It's built on the same principles as Kubernetes itself, is based on the QP project, and it's an extension to Kubernetes API, so you can manage both virtual machines and containers workloads using the same API and the same model. Next slide, please. So what we have seen is that our portfolio can cover most of the needs that solution vendors in this space or companies wanted to embrace a solution. And now we are going to jump to a specific use case related to the smart grid. Let's focus on a typical scenario that relies on what we have seen before, the Kubernetes related layer. Again, first layer, the three pillars. We are going to use Rancher to manage all those devices. We are going to use Fleet to be able to control how we are going to distribute the software to all those remote locations. And we are going to use New Vector to secure both the interconnection, okay, so the network layers, a layer 7 and also a layer 4, and the behavior within the container, what containers are doing. Another component that is going to be important in all this containerized architecture is what we call BCI. SUSE BCI, it's just an evolution of what we have seen with SLS and Slim Micro. SUSE BCI is SUSE-based container image. So we have taken all those benefits we have in terms of secure software building process certification, and we have reused them to create the most advanced and secure container in the market. When you are working with containers workload, that means that you can have both a lightweight solution that can be fully supported by us and that inherits many of the certifications that you can expect on a traditional Linux distribution. So ISV, or solution vendors in the space can use BCI as the foundation for the containers where the edge management solution will rely on to run their application. So we have the management, the circuit distribution management security layer, the base container image to create the containers that are going to host our application, and then the platform for deployment. It's quite common, and we will see it in more detail later on, that we have central services and remote devices, and all of them will run Kubernetes clusters. On the central services side, on those places that we need not only a Kubernetes distribution, but to have more platform services, we will be deploying RK2, Kubernetes distribution with a lot of services, for example, like full stack monitoring with Prometheus, Grafana, service mesh like Istio, all those typical services that we may need for the application that will control our network will be available for AK2, whereas on the left side for our small full clean devices at the edge, we will use K3S. To deployment option, okay? If we are going to run in the cloud, we can consume cloud resources that can run in terms of super enterprise Linux, but it's quite common, as we described, on smart grid and telco use cases that we have regional data centers or regional point of presence. Those are environments that give services to a specific region or to a specific set of devices, okay, because those networks have a distributed nature, okay. And on those environments, through the use of Harvester, we can provide both a foundation to create virtual machines and to deploy Kubernetes clusters. When we move to the edge, depending on the edge and the size, and that's driven by the use case, we may also need to deploy a thin virtualization layer through Harvester, or we can just rely on SLE Micro to run our K3S distribution. Next slide, please, Andres. So here we are going to try to map the example that Andres described at the beginning with the components that we should place in each of those layers. So again, a distributed model and a smart grid. Our utilities company will have a central control around that, but this smart grid, Andres was talking about the small village, are local in nature. So usually energy generated here is not exported to remote locations, so it's consumed at a local level. That means that we will have a set of regional data centers or regional compute facilities. And then we will have our components. Which components or which, let's say, smart grid components are the more relevant? These are the ones that have capabilities in terms of production, okay? Or sometimes about storage. So here we have the three examples. On the right side, a pure production environment. So it's a house with an internet connection and solar panels. In the middle, just a storage. That house is not able to produce electricity, but has a value for them smart grid that either batteries there or electric car can act as a storage that can help in the stability of the network. So we will also consider that. On the left side, we have both. Okay, we are combining a producer because it has solar panels and it also provides storage. As Andres said, okay, we need to place compute there to manage all that, and solution providers in this space have the hardware to cover all that. And there is where we are providing full clusters, most of the time single node clusters around K3S running on top of SLE Micro on ARM devices. So that will be what the customer will have at home. It will be similar to traditional internet access equipment, and that will be the foundation for our smart grid system. Who will control that? Our regional server. Okay, our regional server will have additional capacity, so it will be running Harvester and RK2 as Kubernetes distribution. All the regional servers will be placed there, and on the cloud side, we will have another RK2 cluster with the central management services. all of those clusters will be connected to Rancher. Okay, a single Rancher environment is able to manage hundreds and thousands of clusters. So we can have a single point of control, as we described at the beginning, and having Fleet as the driver for the distribution. Okay, Fleet can control the distribution based on set of clusters. So a single fleet environment can control the different regional environments with their own characteristics. So the software delivery can be specifically tailored for those regions, and all of that controlled by the security layer provided by New Vector. And that's all. We have a lot of background and a lot of reference in this space, and yeah, hope you found it useful. And back to you, Andres.
Thank you, Juan. So now let's talk a little bit about conclusions. So basically, we said today like 1,000 times that edge is everywhere and is growing, and the amount of devices is growing, and that has implications. Our conception of hybrid cloud needs to adapt to this changing situation. So now edge computing is becoming strategic for the organizations, and the distributed compute at the edge will be part of our thesis. So will be part of our hybrid clouds. This will mean that our management duties will be more complex, that our exposure, security exposure will be bigger, and compliance and security and also configuration will be more important than ever. Management capabilities will be also crucial to be successful in such an environment. And how suse can help here. For this complicated and fast growing and changing environment, having the right partner with right solutions and skills is key to be successful. So we can help you with our experience in security, Linux, Kubernetes, and management, but also take into account open source. Open source software provides flexibility, independence, and neutral tools that your organization will need for this complex scenario. Imagine in this scenario being logged in by a single vendor that doesn't provide standardized tools. That's something that you really don't want. Then solutions like so SUSE Linux Enterprise Servers, SLI Micro, BCI, K3S, RKey, RKey2, New Vector, and Rancher will help you make the difference on your edge journey. And this was all for today. I hope you liked the session. And now it's time for questions. So feel free to ask. Thank you for being here.